Good morning, sir.
Good morning, Dr. Vashi.
How are you, sir?
I'm fine.
Sir, good morning.
Good morning, Dr. Sambir.
Good morning, sir. Namaskar, sir.
Good morning, Dr. Harsh.
So, sir, can we start now?
Yeah, I don't have any problem. I can start. Should I start
Dr.
now?
Vashi, Dr. Vashi, we can wait 2-3 minutes because the time is 11. 1 minute
Yeah,
is.
okay, no problem.
Okay,
Huh?
okay, fine.
Yes, good morning, sir.
Good morning, Dr. Rajneesh.
Okay, Dr. Samavir, can we start now? Is
Yes,
everything?
yes, please. Sir से पूछ लो एक बार.
So, distinguished guests, respected professors, esteemed faculty members, it is my utmost pleasure to extend a warm and heartful welcome to each and every one of you as we gather here today in this online keynote address for ICS CCC conference. We are honored to host this prestigious event and have the privilege of welcoming every one of you from various institutions who have graced us with their presence. We are incredibly fortunate to have our esteemed keynote speaker who do not need any introduction as well as we all know him by his work in the field. He is an accomplished individual with expertise in the field of computer science and engineering from IIT Roorkee. With the wealth of knowledge and experience, he has established himself as a highly respectable figure within the department. His expertise encompasses several domains within CSC, which includes artificial intelligence, data science, computer networks and communications, software engineering, and cloud computing. His expertise extends beyond the classroom and research lab. He actively participates in academic conferences, seminars, workshops, sharing his research findings and collaborating with fellow experts in this field. His contribution to the academic community have been widely recognized and have earned him a reputable standing in his discipline. With dedication and passion for computer science and engineering, he has significantly impacted the academic community at IIT Roorkee. His commitment to excellence in teaching and research has not only influenced the lives of students but also contributed to the advancement of CSC department and the institute as a whole. I warmly welcome Professor Manoj Mishra to this event. Welcome you, sir. Over to you, sir.
Okay, thank you, Dr. Urvashi, and good morning, everyone. I hope that I'm audible to everyone.
Good morning, sir. Yes,
Good
you are
morning.
audible.
Okay.
Good morning, sir. Yes, sir, you are available.
So without any delay, what I'll do, I'll share my screen and then I'll start the presentation. So is my screen visible?
Yes, it is visible, sir.
Okay.
Yes, sir.
So we'll talk about authentication in general today, and I'll share some of my work that I have done in this field with my students. So the initial presentation will include some of the basic things about the authentication, and then we'll go for the work that we have done in this field, highlighting that what are the needs in this area and what type of work and is going on in this area. So why actually we need authentication? So all of us, we are aware about or we talk about the cyber security, cyber threats these days. So like CNBC TV, a survey conducted by them, it says that India is among top 3 countries in terms of the highest number of internet users in the world. In fact, China is at the top and India is at the second. And the report, it gives some details like though China is at the top, but only 50% of the population of the China it uses internet. India is at the second place, but only 25% of the population of India uses internet. And countries from US and from Europe who are at places third, fourth, fifth, they are at that place, but 90% of the population it uses internet there. Then another survey by BlackBerry, which they have shown on their blog, it also says that India is among top 10 most affected nations in the world in terms of cyber attacks. And in fact, if you read that blog, it actually gives a attack-wise description. So if you go for the ransomware attacks, then you will find that India is at the top there. So when we started working few years back, when I started working in the area of network security, so since then when we worked on many different areas related to security, we worked on authentication, phishing, network forensic, and all those things. So while working in this area, we identified that buggy software and device misconfiguration, though these are the main reasons why these cyber attacks they happen. So we have vulnerabilities in operating system, we have vulnerabilities in other type of softwares which the attackers they exploit, and exploiting those vulnerabilities they perform attacks. Sometimes the system administrators they have not configured the devices properly, the ports which should be closed they are not closed, the daemon processes which should not run they are running, and these things they lead to attacks by the cyber attackers. But along with this, lack of proper authentication and use of weak or compromised credentials is another major reason of these attacks. And you will find that most of the authentication protocols that have been proposed, you may be aware of the very old when 802.11b, the authentication protocol WEP, which was proposed at that time, and later on it was found that it has many drawbacks, and exploiting this or compromising this protocol is very easy. And then WPA came into the picture. So lack of proper authentication and weak or compromised credentials, sometimes we are using very weak passwords, we are not using multi-factor authentication. These things they also lead to cyber attacks. obviously, the lack of attention and lack of technical knowledge is another reason why these cyber attacks they happen. Yeah. So sometimes our browser says that please don't open this website, it is dangerous, or our mail client it says that don't open this mail or don't open this attachment. Still we don't care about those warning messages, and many of us who use internet, they may not be aware that what a lock in the browser window it denotes, what is the difference between http or https. So these things they are also the reason of cyber attacks. So as I said, that lack of proper authentication and weak or compromised credentials, they are one of the major reason behind these cyber attacks. So in today's talk, I will basically focus on these things. So I will basically focus on authentication part of this. So what exactly is authentication? So authentication means we are verifying the identity of a man or machine or message. So if he is claiming that he is Mr. X, then actually whether he is Mr. X or he is not Mr. X. So that is what the aim is when we are doing the authentication, or the aim of the authentication protocol is. And when we are talking about the authentication, then there are many areas where the authentication may be needed. For example, we may need to authenticate the origin of the data. Clear. So this basically is nothing but the message authentication, which also includes checking the integrity of the data. That is, the message has not been altered in between when it traveled from the source machine to the destination machine, and checking the freshness of a message is also important. However, in this talk, we'll not talk about the message authentication and the protocols which have been proposed for authenticating the message or for authenticating the origin of the data. Rather, we will focus on entity authentication. When we talk about the entity authentication, it can again be a host is authenticating another host, a host is authenticating the user, or a host is authenticating a process. And we'll touch upon all these things. And then in many cases, the authentication protocol is also used for establishing the key. So generally the two parties, they share a long-term key, but when they are sending the information in the encrypted form during a session, then instead of using that long-term key, generally it is preferred to use a session key, which is different in every session. So this authentication protocols, they are also used for sharing that session key between the two parties. So authenticated key establishment is another area, or rather most of the protocols, they do this. Now, understanding the difference between authentication, authorization, and encryption. So sometimes, like authentication, authorization, and encryption, these are three different things, but they are related to each other. Generally, authentication is followed by authorization, and we use encryption techniques for authentication. So when we are talking about the authentication, it is nothing but a user or computer, it has to prove its identity to the server or the client. So either the user, you are logging in, you are using your Gmail, you are logging in and you are proving that you are actually the legitimate user, or you are accessing the Google server and you want that Google server should prove that it is actually the Google server. So when we are talking about the authentication by a server, then it involves server needs to check that who is accessing the information which is available on its site, or who is accessing its site, which usually involves the use of username. You are giving a login name, you are sending a password. There may be some other authenticators that you may send. So other ways they are also used, and we'll talk. When it is authentication by a client, say if you are using a browser to access a particular website, so it is when we are saying client, is generally the browser that checks that whether the site is authenticated or not. So it usually involves the server giving a certificate to the client. Now, authentication does not determine that if a person it has been authenticated, what it can do or what files or what resources it can access or it can see. Authentication simply tells that, okay, this is Mr. X, if he is claiming that he is Mr. X. So in order to decide that what resources that particular person can access, so if it is a database server, what information the person who has logged in successfully can access and what information he cannot access, then we need authorization. So authorization is usually coupled with authentication so that the server knows before giving permission to those resources for which the user is authorized to use those resources, he needs to check that who the client is or who the user is. Now, in many cases, when you are surfing on the net, you will find that there are many websites where there's no authorization or authentication is needed. Any user may access or may use any resource or may access any file simply just by asking for it. So most of the pages on the internet, they may not require any authentication or authorization. The other thing is encryption. When we are sending the information, particularly on the internet or on any network from a source machine to destination machine, there is always a chance that this messages that you are sending or the information that you are sending, it can be captured by an adversary. So what to do? So then we have to send this information in order to hide it in the encrypted form. So in a form which so that it is unreadable by anyone who does not have the decryption key. On internet, normally the SSL or TLS protocols which are used when you are using HTTPS, and all data in SSL transaction is encrypted between the client and the server. So when your browser is sending the information to the web server, it is encrypted before this information is transferred. And that is why we can transfer credit card numbers, our password easily on the internet without worrying that this will be intercepted in between and someone else can see that what this credit card number is or what my password is. So this is about encryption, where we are actually encrypting the information so that the information cannot be seen by the persons who are not supposed to see it. But then encryption keys, they can also be used for authentication. So in this talk, I'll basically focus, as I said, on user or entity authentication. So I have done some work with my students basically on 5G authentication, the work we are doing on 5G authentication these days. And earlier, while working in the area of phishing, I did some work where we explored various multi-factor authentication schemes, and we found that these schemes are also prone to different type of recent attacks which the attackers they are using these days. So we'll talk about these things in this talk. And then whenever you are designing any authentication protocol, so we cannot say that this authentication protocol can handle every type of attack. We have to first specify that, okay, this is the attack vector that we are considering and our authentication protocol can handle all these attacks. Or we have to specify the threat model, and this threat model actually specifies that what an adversary can do and what an adversary cannot do. So we'll see some of the popular threat models which are used normally for checking that whether authentication protocol can survive even in presence of many different kind of attacks, or it is prone to or it is vulnerable to these attacks. And for that, formal analysis is also needed, and there are very few methods that can be used for formal analysis. So this is one of the area where research is actually required. In most of the cases, you will find that the researchers who are proposing authentication protocols, they are doing either informal analysis, or if they are using formal analysis, then as we'll see later on, many of these methods, formal analysis methods, even if you have used and these formal analysis methods, they say that this authentication protocol is safe, or rather it is not vulnerable to these attacks. Later on it was found that in fact either some of those attacks they may happen on this authentication protocol, not because that formalism was wrong, but because some of the other reasons that we'll see, or there are some new types of attacks that the adversaries they have started using which have not been considered while doing the formal analysis, and that is why the authentication protocol can be broken. So as I said that we'll talk about entity authentication. And when we are talking about the entity authentication, basically the person, he has to prove that who he is, who he or she is, and for that generally different type of authenticators which are used. So the verification categories or the categories of these authenticators, they can be mainly grouped into these categories. Many of you may be knowing about these categories. So what you know, what you have, and who you are. Other than these three categories, there are some of the other things which are also used by the new authentication techniques. For example, your location can also be used for authenticating that whether you are the right user or not. So these are some of the things that may be used in the category what you know. So your password, it can be your password, it can be a passphrase, or it can be a PIN number. When coming to the category what you have, it can be a physical device. It is generally a physical device to aid the authentication, which can be your ATM card, it can be an e-token, it can be a smart card, it can be a RFID tag. The third category, which is basically related to the biometric authentication, it uses some kind of biometric reading to confirm that a person is who he or she claims to be. So if I am claiming that I am Mr. X, I am actually Mr. X. So in biometric reading, a recording of some physical or behavioral attribute of a person is used. And these are some of the examples of these physical and behavioral attributes. For example, it can be your fingerprint. So all of you know that, for example, in your Aadhaar card, your fingerprints, they are used. Clear? So it can be your fingerprint, it can be your iris, or it can be your hand geometry. Similarly, when we are talking about behavioral biometrics, it can be your signature, it can be the way you walk, it can be your voice, it can be the way you write, and all these things they can be used. Or the way when you are working on the keyboard, you are typing something, how hard you press the keys, how long you press the keys, these things they can be used to verify that whether the person is the person who he or she is claiming to be. The oldest method of authentication is basically password based authentication. Now, this was there even when there was no network. So you have a mainframe and there are many terminals attached to it, and the users, they are going to the computer center and they are sitting on those terminals, and in order to use the mainframe, they have to enter their login name and they have to enter their password. Clear? So here Alice is the claimant, Bob is the verifier. Alice sends a password. So these days we are sending this on the internet, and when we are sending it on the internet, then this password, if we are sending it in plain text, it is not recommended. So it should be encrypted, and encryption comes into the picture there. Sorry. So then on the servers, or the password is generally stored in the hashed form, and almost all servers, they use some kind of salt which is concatenated with the password, and then it is hashed, so it is stored onto the server machine. So when the Alice, which is the claimant, is sending the password, then this password is concatenated with the salt which is stored in the password file. A hash is taken, and if this hash is same as the hash value stored into the password file, then the Bob can verify that it is actually the Alice. Many attacks, they have been designed, so dictionary attacks, rainbow attacks on password based authentication, but we will not go through them. Now in password based authentication, the claimant actually proves his or her identity by sending the password on the net. So he demonstrates that she knows a secret, he or she knows a secret, which is the password, by sending it. Methods where the claimant proves that he or she knows a secret without actually sending it involves encryption. So we have symmetric key ciphers where both the Alice and Bob, they share a secret key. So when Alice wants to start a communication with the Bob, Alice sends a message to Bob that, okay, I'm Alice and I want to start a communication with you. And Bob sends a challenge. So normally it is called challenge response type of protocols. So it sends a nonce RB to Alice, and Alice, it encrypts this RB using the secret key which is shared between Alice and Bob. When this encrypted nonce it reaches to Bob, after decrypting, if Bob finds that it is the same nonce, Bob is sure that it is Alice which is talking to me, because only Alice knows this secret key and no one else knows this secret key. And actually Bob has verified Alice. So Alice has been authenticated by the Bob. So it can be used in bidirectional direction. So Alice can authenticate Bob and Bob can authenticate Alice. Now, when we are using nonce, in fact, nonce can also use timestamps, but when we are using nonce, you see that in these protocols, the number of messages exchanged between Alice and Bob, like in this case, which is a one-way authentication, 3 messages they have been exchanged. This can be reduced to 1 if we are using timestamp, but using timestamp on the internet, it requires that the clock of Alice and Bob, it should be synchronized, which is a difficult task in a distributed environment. You may have heard about the clock synchronization, synchronization of the physical clocks in a distributed environment, and what are the challenges in that, and what is the clock synchronization protocol which is used on internet for synchronizing the clock if the two parties they want to synchronize the clocks. But if clocks are synchronized, then Alice can simply encrypt its ID and a timestamp using the secret key. And when Bob receives this, Bob can verify that the message is actually coming from Alice, as well as because of this timestamp which is attached here in this message, Bob can also verify that the message is fresh. As I said, that the freshness of checking the freshness of the message is also very important. Otherwise, one of the common attack is the replay attack, which the adversary can do. Here, the freshness is checked by, because Alice is returning back this nonce, and this nonce says that this message is fresh because just now Bob has sent this nonce to Alice. Here, this freshness is checked because of this timestamp. Now, similar to these, as we have used this symmetric key cipher here for authentication, asymmetric key ciphers, they can also be used for authentication. So here, when Alice wants to prove while communicating with Bob its ID that I am actually Alice, it sends a message to Bob. Bob sends a challenge. Now this challenge, which contains this nonce RB, it is encrypted using the Alice public key. So in asymmetric key cipher, as you may be knowing, that we have a pair of keys, a public key and a private key. Public key is known to everyone. Thou known to everyone is also something which need actually discussion. Clear? So that wrong public key is not known actually. But anyway, we are assuming that public key is known to everyone. So Bob encrypts using the public key of Alice. And when Alice decrypts it and sends back this nonce to Bob, Bob knows that Bob is communicating with the Alice because only the Alice knows the private key. This can be used for bidirectional authentication also. Now, on internet or in an open environment, it is very difficult, or rather, we cannot expect that every pair of parties, clear, so because there are millions of users and there are thousands of servers, clear, so every pair, they share a secret key in between them if we need to use symmetric key encryption for authentication, or everyone has a public private key pair and the public key of everyone is known to every other person. So here comes the role of trusted third party. So where we have a trusted third party and everyone knows that, okay, this is, everyone shares, in case of symmetric key encryption, everyone shares a secret key with that trusted third party. And then with the help of that trusted third party, a key can be shared between the two parties that want to communicate. So trusted third party protocols, they were being proposed for such an open environment, and Kerberos is one of the popular protocol or the authentication service which was developed as part of the project Athena at MIT. Yeah. So the environment which is assumed for this particular protocol, that we have the users which are using the workstations and they want to access the services which are provided by the services. All these workstations, they are, and the servers, they are distributed throughout the campus and connected with each other through a network. So the protocol can be used for mutual authentication. It relies on symmetric encryption and it uses an authentication server and a ticket granting service. Again, we will not go into the details, but like original third party key distribution protocol was Needham-Schroeder protocol. And this protocol actually initiated the field of cryptographic protocol design, which led to Kerberos and many other modern protocols. In their landmark paper, Needham and Schroeder, they also identified that a very rigorous protocol analysis is needed when we are proposing an authentication protocols, because these protocols, they are prone to extremely subtle errors that are unlikely to be detected in the normal operation. As we'll see that the 5G authentication protocol proposed by 3GPP, so some of the attacks, they may happen or they actually use some of the error conditions in order to attack the protocol, which normally will not happen, but if they happen, then the protocol can be attacked. So the techniques to verify the correctness of such protocols are needed. So what may go wrong? So many simple attacks against protocols have been discovered over the years, and it has been seen that even very carefully designed and very widely deployed protocols, and even often years after, maybe after 5 years or 6 years, someone identifies that this protocol is vulnerable. So for example, SSL, Secure Shell, WEP, as I said, so now we use WPA, so probably it is WPA3 that we use these days. And then 5G ACA protocol proposed for 5G. After it has been, so a version of ACA is also used in 4G and 3G. So after it has been proposed, then many researchers, they identified many attacks that can happen on this protocol. So we have worked and we also identified some of the attacks, and we have proposed some modified versions of 5G ACA that we'll talk about during this discussion. And in many cases, what happens, as I said, that when the researchers, they propose a protocol, they use some formal method and they say that, okay, my attack protocol or my authentication protocol is foolproof, my technique is foolproof. And the proof normally assumes, or it assumes that at lower layer, because the protocol is using encryption, on top of that, using those encryption techniques, we have designed the protocol. So the protocol is safe because those encryption uh, techniques, they cannot be broken, or these are safe. So the type of encryption that we are using, because it is safe, and that is why my protocol is also safe. But what happens in many cases, it has been shown that an adversary can attack the protocol even without breaking the crypto that it has been used. So there is no need to decrypt the information that we are sending. Even without decrypting that information, the adversary can attack the protocol. So why this problem is actually difficult? The problem is difficult because of the concurrency. Many instances, they are the protocol, they may be running at the same time. Participants are distributed. They are not only distributed, participants in most of the cases, they are mobile also. And in many cases, the use of cryptographic operations is itself incorrect. So it is not that cryptography is incorrect, rather the way it has been used is actually incorrect. Normally, while analyzing these protocols, we assume that the adversary or the attackers, so we have active attackers, we have passive attackers. So whether active or passive, in case of passive also, that is full control of communication. So normally, while doing the analysis, the researchers, they assume that the adversary is actually owns the network, so it can do anything. Any message which is traveling onto the network can be captured, can be modified, can be replayed by the adversary. So we'll talk about the threat models, and we will see that the analysis actually depends very much upon the threat model that has been used. The other problem is that generally when we propose these protocols, and when these authentication protocols, they are proposed, the researchers, they assume something, that okay, one of the assumption maybe, which is very commonly used in many cases, that during the registration phase, the channel is safe. During the authentication phase, the channel is insecure, and the information can be captured, it can be altered, it can be replayed. But when the registration is going on, which happens once only, obviously, the channel is fully secure. In some cases, this assumption may not be true, and then the protocol may not work correctly. So the implicit assumptions and goals behind these protocols, they also lead to attacks in some cases. So these are some common type of attacks. Eavesdropping is a kind of passive attack, and generally where the adversary is only listening or capturing the messages. And to avoid this type of attack, encryption is used, so that unless until the adversary has decryption key, it cannot find out that what information is there in that message, even if it captures the message. However, even if this crypto cannot be broken, it has been shown that, like, just by traffic analysis, the adversary can find out many things, many important things. Then modification attack, where the adversary modifies the or alters the message. And again, encryption and authentications are the techniques to avoid that, or to prohibit adversary from modifying the message. So for integrity checking also, hashes can be appended, signatures can be appended. So these type of techniques are generally used. For replay attacks, generally nonce and timestamps are used in order to avoid replay attacks. Man in the middle attack is another type of attack. Reflection attack is a kind of replay attack. And then denial of service attack. So what I will do, I will just discuss denial of service attack. I will skip reflection attack. So in every communication request, so some kind amount of memory, some kind of CPU power, and bandwidth is used. So in a DOS attack, the adversary tries to use up all of server's CPU or memory by making large number of requests. So either it chokes the bandwidth, or there are so many requests, so the CPU is not able to work properly. It is not able to process the legitimate request, or memory is full. All systems, they can be subject to a denial of service attack, but some protocols can make this better or worse. So that we'll see. So a denial of service attack generally does not steal any data or damage any files, but it may cause that the legitimate users, they are not able to access the services provided by the system or the server. So let us see this example. This shows a protocol which is vulnerable to denial of service attack. So A stands for a user and S is the server. K is the public key of A, and KS is the session key which the two parties they want to establish in between them, so that in this session, for encrypting the information which will be exchanged between the two parties, this session key will be used. So A sends its ID and a nonce. Then server uses public key encryption, finds out a new nonce, finds out the session key by performing some cryptographic operation, complex cryptographic operation, and then encrypts NA, NS, and KS using the public key of K. When A receives, it decrypts it, gets the NS, and then uses this NS, encrypts this NS using the session key. So here, not the public key encryption, but the private key, symmetric key encryption has been used. So in fact, the symmetric key encryption is much cheaper in comparison to public key encryption. It has been shown. So here, the server is particularly vulnerable to a DOS attack because it has to generate a nonce and a key. And for generating this key, it is performing a complex cryptographic operation. It has to perform a public key encryption where the user is doing very less work in comparison to the server. Now see this protocol, which is actually resistant to denial of service attack. Here actually user is doing most of the work. User is performing some cryptographic operation to get the session key, find out the nonce. Then it is again performing an expensive operation on this nonce and the session key and sending this to the server, whereas server has to simply decrypt the information and then encrypt using symmetric key encryption the nonce, and it has to send to the server A. So the idea behind this is that if we want that our protocol should be resistant to denial of service attack, the protocol should be designed in such a way so that lesser number of messages are exchanged, size of the messages they are small, and the server has to do less amount of work in comparison to the user. So in this case, A has to do expensive encryption and other operations in order to make S to do more than just a single decryption. And therefore, if someone tries to, an adversary wants to perform a denial of service attack, many more bots would be needed for a successful attack. So there are some other attacks that we identified when we started working on phishing. So we found that real-time man-in-the-middle attack is another attack, and control relay man-in-the-middle attack is another attack. And we found that many multi-factor authentication scheme, though they are safe against earlier attacks, but they cannot handle these two attacks, real-time man-in-the-middle attack and control relaying man-in-the-middle attack. Now, when we are talking about mostly the protocols which are used not only for authentication but also for session key establishment, There are many other type of attacks that we need to check while designing these protocols. And I have listed just two, but as the talk goes on, we'll discuss some more. So like perfect forward secrecy is one of the attack. What it requires that, as I said, that we are using a long-term key, and we are using a session key. Session key is for short-term use. So even if the long-term credentials are exposed, so adversary knows them, adversary should be able to only find out the session keys which are used for encrypting the information in that particular session and the session keys for of future sessions. Adversary should not be able to find out the session keys of previous sessions. Clear? And then session linkability attack, which is very much needed to ensure the privacy of the user. So if a user is establishing multiple sessions with the server, then the adversary should not be able to link these sessions. Adversary should not be able to find out that all these sessions have been established with the server by the same user. In fact, the type of attacks or the attack vector, it depends upon the application or the scenario for which authentication protocol has been designed. So let me start with the work that we did on 5G ARCA protocol. You all know 5G, and I hope that all of you use 5G mobile phones, which is a 5th generation technology standard for broadband cellular networks. 5G ARCA is an authentication and key management protocol or the procedure which not only involves mutual authentication between the users. So one of the things that it does is the mutual authentication between the user device and the network. It also derives crypto keys for secure communication. So that is the another task of this particular protocol. And this protocol was proposed by 3GPP, the third generation partnership project, which is an umbrella term for a number of standards organizations which develop protocols for mobile telecommunications. So let us see this and what work we have done in this area. So we'll discuss about some of the attacks which have been identified. So this is the general scenario that we will assume. Clear? So we have a user equipment. This user equipment is uniquely identified by its subscription permanent identifier in terminology of 5G, which is SUPI. So this is same as your IMSI, which we say the International Mobile Subscriber Identifier, which is stored on your SIM. So in this case, we say that is stored in the Universal Subscriber Identity Module, the USIM. USIM, so your SIM also stores, other than your identifier, it stores some other information also. So similarly, USIM also stores subscriber related information, and it also implements some of the security functions which are required to run the ARCA protocol. In fact, we are talking only about 5G ARCA protocol, but 3GPP has proposed 3 different protocols that can be used. So 2 of them were common. So 5G ARCA protocol and EAP ARCA protocol, they are mainly used for authentication. So we have a user equipment, and because the user is mobile, so UE plus USIM we will call as subscriber. So because user is mobile, so it is not always be possible for the user to connect with the some base station which belongs to its home network. So we have a home network. So probably the user has the SIM of say Airtel. So the network of Airtel belongs to its home network. But when it is on move, when it is mobile, it may connect to some other base station belonging to some other roaming carrier. So that we'll call as the serving network. So the home network is responsible for the registration of their subscriber and their authentication, whereas the serving network, it refers to the network to which the UE may be attached, and it is different from its home network. So it may be its home network also, but for this discussion we will assume that it is different from its home network. Now, in addition, you will find that most of the protocols, the 5G ARCA protocol and many of its variants, they assume that the channel which is used for communication between the serving network and the home network, it is secure. So the secure communication channel. So it is secure. Whereas the channel between UE and SN, this is unsecure. So when we are sending information on this particular channel, we don't have to worry about adversary capturing the information and finding out what we are sending. We have to only worry that what information we are sending on this channel. Some of the protocol, in fact, we have also proposed a protocol where we have assumed that both of these channels, they can be insecure. And in that case, what type of attacks that may happen, additional attacks that may happen, and how to handle those attacks. Now, this is the basic 5G ARCA protocol where the SN is sending authentication request and its name, and then the UE sends SUCI. So this SUCI, in this, it sends its SUPI and a random number that it has generated, encrypted using the public key of the home network. So this is the information that has been stored on the USIM of UE during the registration phase. And this is the information which has been stored into the database of the home network during the registration phase. So this information is available both with user and with the home network. So the user has this information on its USIM, and the home network, the server of the home network, has this information in its database. So the three main messages are exchanged, and we'll come to them. So it sends SUCI in, after receiving SUCI, the home network, so it is received by SN forwards it to the home network, and home network does some computation, finds out this concealed sequence number. So both the parties, they are using a sequence number in order to avoid replay attacks. So user equipment, it has a sequence number, and the home network, it has a sequence number. So at a particular time, these two sequence numbers, they may be different, and the sequence number of home network is different for each user. Clear? So it calculates MAC and a concealment of sequence number and sends this MAC and this concealed sequence number in AUTN. Clear? So along with the random number that it has generated. So this information, it goes to the user. User gets this information from AUTN, and because it knows key K, so it calculates AK, gets sequence number of the home network, calculates MAC, and compares if MAC that it has calculated is same as the MAC that it has received, and it checks that whether sequence number that it has in its database, which is the user equipment sequence number, is less than or equal to the sequence number of the home network that it has received. If both of these checks are passed, then everything is okay. It calculates these two values, RES, and in fact, this is the session key KSEAF. It calculates these two values and sends RES to the serving network, and serving network passes it on to the home network, and here the authentication completes. These two are the error scenarios. Clear? Here the synchronization fails. Synchronization fails because the sequence number of the user is actually greater than the sequence number of the home network, which should not be. And in that case, the user equipment, it calculates MAC and this concealed sequence number, where it is concealing its own sequence number, because now the home network has to set its sequence number equal to the sequence number with the user equipment it has, and sends this AUTS. to the home network. In case of MAC failure, it sends MAC. Now let us see what type of attacks that can happen. Now, exploiting the different failure reasons, I said that in this case, exploiting the different failure reasons, MAC. So one failure reason is where the synchronization fails. Another failure reason is where the two MACs, they do not compare with each other. They are not same. So it can lead to tracking of targeted subscribers and can represent a major privacy threat. How? Let's see this. To detect the presence of a victim mobile station in one of the monitored area, what the adversary can do, adversary can capture this message. Adversary can capture this message. And later on, at some other point, adversary can send this message to the user equipment. Now what will happen? If the user which the adversary is targeting, it is trying to find out that whether this user is present in this region or not, that user will successfully perform this comparison and there will be no MAC failure because this key is same. But there will be a synchronization failure because by this time the sequence number of the user has increased. So it is more than the sequence number of home network which is in this AUTN, and then there will be a synchronization failure. So this will be for the user which the adversary is trying to monitor. For all other users, because the key K is not same, so there will be a MAC failure and there may be a synchronization failure also. So adversary will replay this each time it wants to check the presence of the user equipment or the mobile station. On reception of this, the victim mobile will successfully verify the MAC and will send only synchronization failure message. Whereas other parties or other user equipments, they will send both synchronization failure message and MAC failure message, or they will send MAC failure message. And using this, the adversary can check that whether the mobile station or the user is in this region or not, and it can track the user. So this is one violation, major privacy threat which was identified. Then the another is that in one of the paper, one of the researchers, he actually demonstrated that the sequence number concealment mechanism is not sufficiently protected. And sequence numbers, they can be actually leaked. Let us see how. Now in this case, again, adversary captures this message RAUTN. So this is the message which adversary captures. This message is captured by the adversary. And it captures this message it transmits this message to the UE at two different times, T1 and T2. Now, because this is two different times, so at that two different times, the sequence numbers of the user equipment, they will be different. So user equipment, if it receives this two times, the same challenge, and it yields two synchronization failures, what will it send? It will send AUTS. And what will be there into that AUTS? AUTS will contain concealed sequence number and MAC. Ignore this MAC, focus on this concealed sequence number, and this concealed sequence number is nothing but the sequence number XORed with AK. So in these two messages, it gets a sequence number 1, XORs with AK1, sequence number 2, XORed with AK2, and because this AK1 and AK2, they are actually same. So we can say that this AK1 is equal to AK2 is equal to AK. Clear? Sorry. Is equal to AK. So what we are left with when we are XORing these two concealed sequence numbers, which the adversary has received this in AUTS, we are getting the XORs of the two sequence numbers. Now suppose adversary wants to find out that what is the sequence number of UE. Say suppose it can be any sequence number. So let us focus on the last two bits of the sequence numbers. So they can be 0, 0, or they can be 0, 1, or they can be 1, 0, or they can be 1, 1. So if adversary somehow captures two messages in which the sequence numbers are consecutive, so in what the sequence number is x, in another sequence number is x plus 1. So if the sequence number is x plus 1, then 0, 0 will become 0, 1. These are the two lower order bits. If it was 0, 1, then it will become 1, 0. If it was 1, 0, it will become 1, 1. And if it was 1, 1, it will become 0, 0. So now XOR this. This will be, sorry. So okay, I will show this. So in this case, we are getting a 0, 1. In this case, we are getting a 1, 1, 0, 1. So the same bit patterns we are going to get. Clear? So like in this case, if it gets multiple such sequence numbers and XORs the sequence number x with the sequence number which is x plus 2 to the power I, so at a distance of 2 to the power I, then suppose the initial sequence number was 5, it gets 1, so it was 101, now it has become 6. So when it has XORed it, 1, 0, it will be 1, 0, 1, it will be 1, and then 1, 1, it will be 0, 0, 0, it will be 0. And similarly, delta 1, it is x, and another sequence number is x plus 2 to the power 1, which is x plus 2. So it is now 7, and it gets this. For x plus 2 to the power 2, it is 4, so it is 5 and 9, so it gets this and this. So like in this case, it will get 0, 1. In this case, it will get 1, 1. In this case, it will get 0, 1. And in this case, it will get 1, 1. So only two patterns are coming, 0, 1 and 1, 1. And using these two patterns, this algorithm can be used. So now it can iterate from if it wants to find out the lower order n bits of the sequence number, then it can use this technique and can find out B1 and B2, where B1 and B2 is delta II and delta II plus 1. So the ith bit and I plus 1th bit. If it is 1, 0, then it sets the ith bit of the sequence number equal to 0. If it is 1, 1, then it sets the ith bit of the sequence number equal to 1, 1. So in this case, because it is 1, 1, it will set the lower order bit of the sequence number as 1. Because this is 0, 1, so it is B1, B2. So that means this is B1, this is B2. So this is 1, 0. So it will set the bit as 0. And you can see by capturing these 4 messages, we are able to find out 2 lower order bits of this sequence number. These 2 lower order bits, we have successfully identified that what they are. So they demonstrated that using this, the sequence number can actually be revealed. Then another type of attack is that if the SN is malicious, then SN can capture multiple SUCIs and corresponding RES messages, and if it sends that SUCI and RES, then the home network reveals SUPI of the user to that malicious serving network. So, in fact, there were many other attacks that we identified, and later on we proposed uh, protocols based upon that. So, I will not go into the details of all those things. Clear? I'll skip this part also. We actually, so these days you will find that mostly we are using multi-factor authentication, where we are using more than one factor. Say if you are going to your, for extracting money to your ATM, you are using your ATM card and PIN, and in some cases, if the amount is probably, I think, more than 5,000, you will get an OTP also. So you have three factors which are there that you are using in order to get your money. Adaptive authentication is also very commonly used these days. So let us skip this part. So I'll briefly tell about the threat model. So for any formal method, if you are using, it requires that a precise language should be there, a formal execution model should be there, the description of the adversary capability should be there, and a formal language for specifying desired security properties should be there. So the commonly used threat models which are there. So can I go on for 2 or 3 minutes more?
Sure, sir.
So the commonly used threat models are DY model, which you will find that most of the papers they use. And DY model, it basically focuses on two-party protocols and their secrecy properties, assumes a vulnerable environment, where it assumes that there is a large open network of computers, devices, and resources. There are legitimate communicating entities and there are bad guys. So secrecy property assumes that adversary cannot recover M, which is the message exchange between Alice and Bob, in a secret way, even if it is actively interfering with the protocol. Assumes that the parties, honest parties, are stateless, but adversary can maintain a state. So, like, it also assumes that the concurrent executions are possible, public key infrastructure and public key cryptography can be used, and infrastructure is available. So here we are describing, it describes attacker is a non-deterministic process. It can intercept any message, decompose it into parts, decrypt it if and only if it knows the correct keys, create new messages from data it has observed. But then it says that what attacker cannot do, it cannot analyze actual cryptographic schemes used. If the random number has been taken from a very large space, then it cannot guess this random number. It cannot perform a statistical test, timing attacks, and all those things. So the idea to tell this is that different DY models, these are some of the other threat models which are commonly used by the researchers to analyze their protocols. So CK model and ECK model, these are the two other popular threat models which are used. And these threat models, they give different capabilities of the adversaries. And depending upon that, the analysis of the protocol is done. These are some of the tools that can be used for analyzing the protocol. In fact, my students, they normally use this CIDR protocol. And you see that in CIDR protocol, you can describe, you can tell that what is the threat model that we are using. So you can actually tell that we are using DY model or EK model or CK model or ECK model, which model we are using. It's a Python-based tool available for various platforms. The protocol description that you have to write, you can write in SPDL language, which is, I think, very close to CS. And then ProVerif is another tool. So it's your choice that if you want, if you are working in this area and if you are designing an authentication protocol, you can use any one of them in order to analyze those protocols. Yeah. All of them, they are used by the researchers to analyze these protocols. So I think I'll not go into the details of band logic and all those things, which is a formal model. In fact, the oldest one probably. And after that, there are many other formal methods which were proposed, like GNY logic was proposed, Rubin method was proposed. So I'll stop here. If you have any queries, you can ask.
Participants, if you have any kind of query, you can ask, sir. Yes, Guneet.
Good morning, sir. Thank you
Good
for this
morning.
knowledgeable session.
Good morning.
Thank you, Urvashi ma'am, for arranging it. Sir, actually, I have a question. As I'm a part of project under
Mhm.
Dr. Urvashi, we are working on vulnerabilities. So
Mhm.
my question is like, if there are three vulnerabilities like X1, X2, and X3, they exist, then
Mhm.
what is the possibility that vulnerability Y will be exist? And
See, that is what I said, that like if you have identified that okay, x1, x2, and x3, these are the three vulnerabilities which are already there into protocol, so that doesn't mean that there is no other vulnerability. Later on, some other researcher may find out that there is an additional vulnerability which may exist. But when you are designing your protocol, when you are designing your procedure, so because you are assuming that okay, this is the attack vector, I have considered that okay, these are the attacks which can happen, and my protocol is safe against these attacks. Yes. So obviously, if you have not considered some other attacks, say if attack Y, then you are not claiming that your protocol is safe against attack Y. So even if you are saying that okay, my protocol is safe, then you are only claiming that my protocol is safe against X1, X2, and X3 attack.
so actually, I have a problem of fetching data sets because we are not getting like the complete data set which claims that if these vulnerabilities exist, then there will be a possibility that another vulnerabilities exist. So I just want that can you help us with the approach that what can the approach we use for finding the data set?
So data set, again, I'll say that yes, there are not many data sets which are available that can be used for finding out that okay, what are the vulnerabilities. Like when we did an authentication protocol, in fact, we have not used any data sets. We have done informal analysis, and by doing that informal analysis, we have identified that okay, these are the vulnerabilities that exist. Yeah. By saying that okay, some kind of derivation that okay, if uh, adversary has captured this message and then adversary knows this, that you can define by using adversary capabilities, then obviously adversary can find out this particular key, and if it finds out this particular key, then he can find out the information that you are sending. So there actually no data set was needed. While working on phishing, obviously we have used some data sets that probably I can share with you offline, because I don't remember that from where my in other security related work, my students, they have used data sets from Kaggle and that well-known data sets which was where many network attacks they have been there. I don't remember the name, but I can share if you want. But yes, when working on authentication protocols, we have not used any data sets.
Okay, sir. Thank you for this, sir.
Okay.
I'll get your email from Urvashi ma'am.
Yeah,
Then I
sure, sure. So there are data sets that we have used while working on phishing protocols and identifying the vulnerabilities there. So I'll share those data sets that my students they have used. But while working on authentication protocols, particularly on 5G authentication, 5G ACA protocol, we have not used actually any data sets. We have actually uh, check the protocols published, the 5G ACA protocol published by 3GPP and the other variants of this published by the researchers. And by doing informal analysis and by doing some derivations, we have actually shown that, okay, these are the attacks which are there. So for identifying those attacks, we have not used any data sets.
thank you, sir.
Yes, Jyoti, you want
Yes,
to add
Jyoti.
something? Yeah.
Good morning, sir. Good morning, ma'am, and good morning, team. Thank you, Roshi ma'am, for getting us chance to interact with respected sir. These days there's a lot of buzz about the term quantum computing, and
Yeah.
even in the Even in this session, you outlined various cryptographic systems, how they're working, and possible attacks. So, with the context, with the same cryptographic algorithms. So, what will be the implication of quantum computing on existing cryptographic algorithms, and how should researchers and the organization should address these upcoming challenges?
Yeah, this is a area where many researchers they are working these days. In fact, in my institute also there are students who are working on this area, and there is a Professor Sugat Gangopadhyay who works in the area of quantum computing. I normally don't work in the. I have not worked on quantum computing, but I know that they normally. Like they are working in this type of things, that whether this particular cryptographic scheme is quantum safe or not,
Or
whether
not?
this
Yes.
algorithm is quantum safe or not. So, and in fact in area of authentication protocols also, now people they have started working on that whether this authentication protocol is quantum safe or not. So that is an area where the government is also giving lots of funding. Is a thrust area for the government, you will find. But actually, because I have not worked in that area, so I'll not be able to say much. But yes, even in the case of authentication protocols, cryptography, many people they are working that whether these things are quantum safe or not. But what is quantum safe, what is not quantum safe, I cannot say. Those people they will tell you. Authentication, in the area of authentication also, these days the people they have started working on quantum safe authentication algorithms.
Thank you, sir.
Okay, that is not my area, so I cannot help much.
Any other question from any participant? So, okay, I guess there are no more questions. Thank you so much, sir. It was such a nice and insightful session.
No, thank you all. It is always nice interacting with all of you.
Sir, actually, we are working on a project like DST project, na? So
Achha,
we are
achha.
working on, and one of the objective was to vulnerability analysis. So we actually have web served some databases like NVD, CVE, CVSS. So
But
we
there are
got
there are many standards defined by the industry also, like what are the attack vectors that you should check,
yeah,
and there are
CVSS.
very many vulnerability analysis tools also which are there
Yeah,
which the industry it uses.
yeah. So we actually want to develop an AI model to actually
Okay.
analyze the vulnerabilities, like two or three vulnerabilities coexist. So I want to fetch how many other vulnerabilities can coexist in future.
Yes,
So
yes.
this kind of work we want to done in one of the
That's a good
objectives.
work. Yes.
So can we have a discussion about this in mail or anything if you
Yeah, sure, sure. As I said that probably uh, one of your student she asked in the beginning, na?
yeah,
So
yeah.
I will tell her about the data sets that we use while working on phishing, and maybe some of the tools also that we use then. So, but yes, I'll be happy to interact with you in this area.
Thank you so much, sir. Thank you so much for such a nice session, sir.
Okay.
Thank you so much.
Namaskar. Namaskar.
Harsh Sharma, sir, you are unmute. Yeah.
Thank you, sir. Thank you very much for being
Thank
with
you.
us.
Professor Mishra, namaskar, sir.
Namaskar, Sangha sir.
It's really nice of you that in spite you are on tour to some other place and we catch hold of you to be with us today this morning session. Thank you very much, sir. For
Thank you.
supporting us all time and how you are always available for helping us. Thank you very much.
Thank you all.
Thank you.
Okay.
Thank you,
Signing
sir.
now, है ना? Okay. Okay, so bye everyone.
Bye, sir. Okay, participant, you can leave for this session now.
Thank you, ma'am.